Okay, so tomorrow for the bake sale we need to do brownies and cookies, and therefore we're in the supermarket. We're gonna buy our ingredients in order to calculate our cost, and tomorrow we will be selling our brownies and cookies.
And we're gonna use math to maximize our profits. Let's go!
Okay, so now that we've done our grocery shopping, having our recipes, we can follow the cost function and come up with one for both the brownies and the cookies that we want to bake. Some ingredients will be shared and some others will only be for one of the two products. So we came up with a cost function that puts together the ingredients, taking in account their cost, and ultimately gives us a function for each and every brownie or cookie that we want to bake. Following, we came up with the revenue function. So because we are going to sell both the brownies and the cookies in bundles, the brownies are going to be 20 euros per bundle, and the cookies instead will be 5 euros per bundle. Now that we know both our cost function and our revenue function, we can calculate the profit function, which is simply the revenue function minus the cost function. So whatever we sell minus the costs of us producing that product. Now let's simplify. Now, because we have all of our functions, we can start calculating how to maximize our profits. Since it is an implicit function and we do have two different products, we're going to have to differentiate with respect to the brownies and with respect to the cookies. Also, in order to understand the max of our profit function, we're going to have to equate the derivative to equal to 0, so that we're able to identify the key points. So now we're going to use these functions to derive B and C by doing simultaneous division. And to do so, we want to cancel C. So we are going to multiply the first function by minus 4. So after doing the math, we get that B is equal to 28.03 rounded up, and C, by replacing B into the equation, gives you 117. These numbers represent the quantity of brownies and cookies at a critical point on our profit function, but what we want to do is check if there are actually maximum points. The way that we're going to do this is by deriving the second derivative with respect to the brownies, and then derive the second derivative of the brownie first derivative with respect to the cookies, and lastly the second derivative with respect to the cookies. And finally check if our two quantities for brownies and cookies are actually local maximas by using the second order derivative rule, which states that if A is negative, which is this case, and AC minus B squared is positive, which is this case, then our profit maximization is indeed at 0.28 brownies and 118 cookies.